I'll tell you just a little bit about myself. Some of you may know me, my background is in Java. I've been doing Java since before it was Java, since '95 or so, when it was a project at Sun called Oak. Back then, I was very much interested in Android, in Java for embedded devices. But then what happened is Java mostly evolved in the enterprise computing. So for the past 10, 15 years, that's basically what I've been doing, mostly enterprise web development. With Java, and then a couple of years ago when Android came out, I got really interested in that. So that's sort of my background. Over the past 2 years, I've been extensively working on Android projects, doing a lot of training. This year alone, that's my statistics I've done, and actually it's kind of outdated, but I've done close to 200,000 miles this year. I've been on the road probably 170, 80 days, something like that, crisscrossing the globe and doing a lot of classes for companies like Qualcomm, Motorola, Sony Ericsson, Department of Defense, Cisco lately as well. And I also often speak at conferences. So I spoke at OSCON a couple of times, ACM, IEEE. I'm speaking at the upcoming AndDevCon, Android Developer Conference, which is in San Mateo in March. And I'm also working on Learning Android. It's a book that's going to be published by O'Reilly. So I'll tell you a little bit about that book because the book is actually came out of this 5-day class. So I've done this class many times and probably over thousands of people. And I sort of saw certain things work and certain things don't work. So over time, I kind of try to distill it down into a book. And that book is currently available online at, if you go to learning-android.com, that's going to forward you to another URL. But that's a good start. So learning-android.com. And a lot of what you guys have in your material. It's sort of that. This is, you can think of it as a rough draft. It's still gonna get edited for language and all that other stuff. So learning-android.com. So right now it's free. It's in a draft version, and it's in this format where people can comment. So you can just go and comment on it as well. So if you see something that's wrong or something that could be improved on, you can just do it there. So that's just a little bit about that book. It's all available here and so on. So far, so good. Okay, cool. So I'll tell you a little bit about what we're gonna do today. So we're gonna talk a little bit about the stack. What Android is and what it isn't. We're gonna do a little Hello World example, and then we're gonna talk probably around lunchtime or right after lunch about the main building blocks. That's something that I think is very important and new in Android. So after that, we are going to talk about user interface, and that's what we're probably going to spend most of the rest of the day on. So that's sort of our plan for today. This initial part here is going to be somewhat more theoretical. But that's just kind of how we're going to start. Don't worry, this is going to be very much a hands-on class, so it's not so much a theory. And the way that we're going to do it is I'm going to walk you through an example. I'll actually be doing it live, and then you guys are going to be doing something similar yourself. And then in the last hour, we'll give you a chance to actually work on a totally different project, knowing what you picked up in the class so far. Sounds good? And I know some of you might have seen some parts of this because you took the overview, which is essentially the first day of the 5-day class. Cool. So, and by the way, feel free to ask questions at any point in time. It's a small class, so feel free to, it's your class, so ask whatever you want to know. So let's talk a little bit about the stack. How many of you have seen this before? A couple of you. Okay, so it's basically the stack of the entire operating system. Android is, as you know, a full-fledged platform. It's got everything we need to get going. So what we're going to do is we're going to start bottom up. We're going to talk a little bit about Linux. We're going to talk about the native libraries, Dalvik, the app framework, and finally we're going to discuss applications. So that's sort of our goal for now. So as you know, at the bottom of it all, it's basically Linux. So Android is based on Linux operating system. Any ideas why Linux?
I would say because one open.
Okay.
A couple of years of proven use,
So it's open.
Yeah, and proven use. If you had to go right to OS from scratch, you got to do a lot of debugging and
Yep.
serious investment.
Yep. So it's open and it works, right? Yeah. Any other ideas why Linux?
Security and also medical care.
So security, yeah. It is an operating system that's been in a very harsh environment, so we know a lot about Linux security, and that dovetails into it's an open platform, so we know what that is. Another thing that I would also mention is that Linux, we understand the driver model on Linux very well, so it's relatively easy to port it. Right. So when Android started as a project, Eric Schmidt basically said, "Look, our goal is not to have G phone, because a lot of people back then thought, oh, Google's working on a G phone, right? The iPhone, G phone, right? And they made it clear right then and there that's not the goal, right? The goal is to have a platform that's going to run on a zillion different devices, and you're going to see how this decision kind of is implemented throughout various parts of software as a platform. So it's basically, we're targeting zillion different devices. So as such, we need a underlying part of the stack, something that's easy to port and implement on different platforms. So portability, security. Security is also important because unlike some other Java solutions, Android outsources its security down to Linux. So like, for example, J2ME or Java ME tends to do more of a security in the Java layer. And that's not the case with the Android system. We basically push the security down to Linux, which is good because Linux we know much more about than Java. So those are some reasons for Linux as the bottom of it all. Linux kernel itself technically is not part of the Android project, and technically it's not a modified version of Linux. In practice, it is slightly modified, but it's based on 2.6.34, I think now. So it's more or less it's a standard kernel. It's just that we use it to build on top of, and it's been modified for various things. We can, toward Thursday, Friday, we can talk more about the internals if that's, if you guys care about that. But I can show you some of those modifications.
Does the Android rely on the dbus?
On the what?
Dbus.
Dbus? I'm not sure. I don't know.
Right now, let's say the dbus is more as a IPC mechanism, between the kernel to user space and also between application.
Mm-hmm.
And let's say Fedora 13 is pretty heavy on the system D. So I'm not sure does Android also take advantage of this dbus.
So Android has its own IPC mechanism using the binder. So there is a proprietary mechanism developed for Android.
Yeah, most of the device driver right now is going to support the dbus interface.
Right.
So let's say if you have a USB device and you plug in, and if your application isn't on the dbus event signal, let's say if you plug in the USB hard drive, if your application will know about that, the resources coming in. And something like the USB camera, if you have something like the IM application, if you plug in the camera, IM will know about that.
Yeah.
So that's why I don't know if there's an Android rely on some of the mechanism or take advantage of this kind of the feature from the index model right now.
Yeah, I'm not familiar about that. I don't really know. So a lot of that is not even exposed, such as USB is not even exposed to the Android, higher layers. So it's kept in the sort of the proprietary part of Linux. Some of that stuff, specifically USB, for now. Any other questions on Linux?
So theoretically, any Linux system can run Android, is correct?
Can any Linux system run Android? Not really. Not really. There's quite a bit of specifics with respect to Android. For example, user management. There's no password file, right? So users are actually hard coded in a C file. The file system is mounted differently. There's no fstab file, right? So it's mounted by initd process. So it's quite different. Everything around the kernel is different other than the kernel itself, right? So it's quite different the way it uses Linux. It's based on Linux, but it's not it's not any standard Linux distribution that you may be familiar with.
So Android is using the Linux file system?
It's not well. It's not using the standard. It's
It's not ESP2, ESP, those kind of.
no. It's a different file system.
So it's more a user space file system.
Yes, it's more of a user space file system. Yeah.
So they're using the Fuse or something like that.
A what?
Fuse, F-U-S-E. Fuse.
I'm not sure. Not sure if you. Yeah, I don't exactly know how that works.
Is Android a GPL license or is it Google?
So the entire stack is more or less licensed under Apache and MIT licenses. Because remember, one of the goals of the project was that it's going to be a platform that many people are going to use for many different devices. So as such, the license needed to be friendly for companies such as Cisco, where you would take this platform and you would build on top of it and make changes to it. So regular GPL as a license doesn't quite work in that case, right? However, we are using the kernel, so that's partially why kernel is a separate project that Android builds on top of, which is GPL, right? But there are some licenses which are GPL or LGPL, but for the most, it's a mixed bag of stuff. But for the most part, it's Apache, MIT type license, BSD, and so on. So.
What is enjoyed the hardware requirements, such as what kind of CPU? They can support any type of CPU or only limited by the ARM process or MIPS?
So in terms of the CPU support, the idea is that a lot of stuff has been designed with portability in mind. That's in theory, right? So in theory, it should be easy to port it to MIPS or to Intel and so on. In practice, they're more pragmatic. They built it for a specific platform, right? So when it comes to porting to a different chipset, you would basically have to take all the libraries, recompile them. Dalvik in itself comes in two flavors, and we'll talk about Dalvik. But there's basically a flavor that is more of a sort of NCC, fairly portable, right? And then there's a flavor that's optimized for ARM. So, but you would probably have to do some work in porting it to a different chipset, right? So, in terms of the minimum requirement, that it really depends. For example, Gingerbread, the new version that's coming out, does require 1 gigahertz as sort of a minimum requirement. But that's not to say that you can't port it to something else. It's just that it's been designed to work with that in mind, right? So we do have Gingerbread and Froyo running on, especially specifically Froyo running on a very old devices on which it's not supported, but it's possible to port. So, but then you're sort of on your own when it comes to portability and all that. Any other questions, Linux? We'll get back to that. So on top of Linux, basically what we have is a bunch of native libraries, meaning C, C++ code, that is more or less copy-pasted from other open source projects, right? So we have other projects that we needed to complete the whole stack, right? So for example, to build an entire system, we needed a database. So we got SQLite database. As a default database. We needed a way to render HTML, so we got WebKit, which is the same engine as Chrome and Safari and many other browsers. SSL, SGL, OpenGL, various media codecs, things of that nature. So that's mostly borrowed from the other projects.
You said those set of the libraries, is a minimum requirement for Android model, or it's not? You said those libraries are minimum requirement.
These libraries are minimum requirement. So first of all, keep in mind that the examples that I took here are mostly for just educational purposes. This is not the finite. There's much larger list. So that's the first thing. Now, what it means to be a minimum requirement. So that's a whole question of fragmentation of Android. What does it really mean to be a valid Android device, right? Because I can take Android and I can strip it down and use it, for example, for home control system or something like that, right? So that's where the Android team just recently came up with the Android compatibility certification. I forget exactly what it's called, but basically that boils down to you certifying yourself or your code that it's a valid Android system, right? And what that means is that there's a battery of tests that you run yourself that's going to check that there are things that a user would typically expect of an Android device, right? So that would check existence of the default codecs, the default database, the default this and that. That's a part one of the test. Part two is more subjective, sort of like you testing that as a user it feels like that. So in other words, you could take Android, you could modify it for some totally different use, like home automation system, or I work with a company that's using it for car, for dashboard, right? Nothing to do with the mobile experience. So of course they strip it down and modify it, but that's fine. They just don't need to call it Android. Nobody ever even cares that it's an Android subsystem. So that's what compatibility. So if you are gonna call it an Android system, it should adhere to certain minimum sort of set of functionality. Make sense? Cool. Any other questions on native libraries? One thing that you may or may not have noticed is Bionic. So that's basically more or less an alternative version of libc library. Okay, so it's a modified, rewritten version of libc. It's been optimized first of all for Android. So there's some things that are added to support Android features, such as like logging, so that there's a common logging framework throughout the system. But also another reason for Bionic is again the license. So Bionic is, I think, derivative of BSD. So it's licensed under those terms, which means you can build on top of it and you get to keep the changes, unlike LGPL. So for the regular license. So that's we'll see that when we talk about the internals later on. Cool. Okay, so what we have next is we have something called Dalvik. So Dalvik is basically the replacement virtual machine. It's an alternative virtual machine for Android. Is everyone familiar with how Java works with its virtual machine? Right. So basically, the Android team, one of the very first things that they looked at, they're like, okay, so if we're gonna use Java as a language, Java as a language is free, Java tools are free, Java compilers are free, but virtual machine it's not, right? So typically, if you're using the virtual machine, you have to license it from Sun, now Oracle, right? So that didn't really work well with the whole goal of having it run everywhere by many different companies and the individuals and so on. So that's why they sort of bit a bullet and decided to create a virtual machine that's specific to Android. And while they were working on that, so one reason is basically a license again, but the second reason is they looked at JVM and Java Virtual Machine. It's been sort of one size fits all for everything from small devices to very large servers, right? And like I said, most of the new development in Java has been more on the server side, not so much on the tiny little battery powered device side. So they felt that if they focus on just the mobile experience, that they can make a virtual machine that's much better performing. And as such, they basically looked at the mobile experience, and they said, what are the things that are not going to change anytime soon? What are the constraints that we're sort of dealing with? And they came up with basically two things. Devices are going to be small, meaning underpowered. and they're gonna run on batteries, and batteries are not gonna get much better anytime soon, right? We're seeing an evolution in batteries, but not an evolution, right? Not a revolution, right? So Dalvik's been optimized with that in mind. So you'll see later on, but it's a very, very tiny footprint virtual machine. And that sort of goes back to, remember how we outsource security down to Linux? So essentially we're going to run every single application on its own Dalvik virtual machine. So unlike regular Java ME solution where you have many, many apps in the same VM space, we don't do that. We have a single process with a single Dalvik VM. So if something blows up, it's just that Linux process that blew up, nothing else, you know. So that's where Linux is sort of managing the security. Linux is managing processes, all that sort of stuff. So we'll talk more about that a little later. Dalvik is now JIT enabled, meaning it's got just-in-time compiler. Is everyone familiar how that works? The just-in-time compilers, like a hotspot in Java. So you cache the code that you interpret on the fly, right? So it makes the end result is the code now runs 2 to 5 times faster with Dalvik when it actually has some running code. So that's a little bit about Dalvik. Any ideas why I picked this picture, other than it's a nice picture?
It's the village called Dalvik.
Yeah, it's in Iceland. Yeah, so that's Dalvik. It looks like that. It's got a church. That's about it. So the guy who wrote Dalvik, his name is Dan Bornstein. He works at Google. Me and him live in the same San Francisco building. It's a 5-people building. I mean, it's small. I don't live there, but we used to have an office at the bottom floor, so I still own the property. So it's totally a coincidence, a small world. I had no idea. So I was like, hey, you do Android too? Huh, interesting. So, but he basically wrote it. So,
Is it ever designed for the multi-core system? Let's say if you have a multi-core CPU, they recognize that each Java is going to run on the Java applications per. And if your Java application is multi-core system, is that can you distribute the multiple core, or you must stay in the same core?
So basically, how is Dalvik gonna handle the threads? Right now, it just does time slicing, but I don't know what's coming out. I don't know yet with the details. Dalvik team usually works like 2 releases out. So they don't even work on Gingerbread, they're working on Honeycomb, so they're like working far out. But I honestly don't know what their priorities are. I would imagine that porting to Intel is one of them. So they just got JIT out, which was a big deal, right? So the next big deal would be to get Intel version out. And one of the big motivations for Intel version is the Google TV, right? So that's something that, but this is again, I'm just speculating. I don't have the details. Keep in mind that, first of all, you guys are part of the alliance, right? The Open Handset Alliance. So sometimes you have a preview of the stuff before general public. So that's one thing. Second thing is sometimes code is actually in there, but it's just disabled. So for example, the JIT compiler was in Froyo, not in Froyo, but even earlier in Android. It was commented out. But it was there in the code. It was just kind of turned off because they were still testing it. So, but I would expect that that's one of the high priority items, support for multi-core.
Because even the ARM processor, the Marvell, they come up with a three ARM processor also, 3 ARM core.
Yeah.
And they were used for the Android and the mobile device or either is a Google TV. So if there is able to say the render is a single processor.
Yes.
Now they are going to take advantage of multi-core.
Yes.
It's very different than JVM before. JVM is one and you can run the multiple Java application on the top. Right now this one application per within the virtual machine is very different.
Yeah, exactly. So the VM itself needs to take do a better job at concurrency. Yeah. Yeah, right now it doesn't, we run it in the emulator, but I run it on a multi-core machine within the emulator, and it doesn't take advantage of the cores. So it just basically runs on one or the other. So
Yeah, step by step.
exactly. Yeah, we'll look at some tools how we can actually measure the execution, so we can actually see how that's working. But you're going to see that time is just time sliced right now. So, yeah. Any other questions on Dalvik? No. Okay, so at the top of that we have the app framework. So application framework is that sort of rich environment on top of which we're going to run everything, right? So it's it's written in Java, but it ducktails into C code. It provides easy access to a lot of features that are maybe more convoluted down below. So for example, if I wanted to find out my location or Wi-Fi networks or get on the internet or make a phone call or whatnot, App Framework makes that very, very simple by providing a nice, consistent Java interface. So that's what it is. That's the part of the system that's very well documented, explained, understood, and all that. So that's sort of the new stuff. Whereas sort of stuff that's below this line, the source code is the documentation. Right? There's not a lot of documentation other than that. So, but stuff above this part we sort of have much better understanding of. Cool. And then on top of that we have apps, right? So we write applications. Now, what an application is roughly it's a single file. It's called an APK file, and that APK file is more or less a zip file, right? So it's basically just an archive of stuff. So the stuff that you get in that archive is sort of two things. I kind of have three here, but it's more or less two. So you have some Dalvik executable, meaning this is the Java code that you write, right? It gets compiled to Dalvik. We'll talk about that in a second. But that's basically the executable code. And then on top of, in addition to that, we have resources. So resources is everything that your app needs that is not code. So what would be some things that your app needs that is not code?
Icons, images.
Images, icons. Yeah. Yeah. Also a lot of XML. So there's going to be a lot of layouts. You'll see how you describe UI using XML. So there's going to be quite a bit of XML code. All the text, all the English is going to be more or less in XML. Right, so we're going to outsource all that from Java to XML. So you'll see how this ends up being a lot of sort of other stuff that you don't necessarily want to pollute your Java code with. So we'll talk about that. So those two things essentially make your APK file. Now I put native libs here just because this is not very typical to have any native libraries as part of your application. But I tend to work with companies that always want to add some secret sauce that's written in C or something as part of their application. So that's why I kind of put it there. Yes, you can have some native libraries as part of that. And we can talk about NDK, which is the native development kit, which is used for that sort of stuff later on. But it's not a typical thing that a normal app developer would do. Just that I assume you guys, the type of stuff you guys do, sometimes you need to deal with that. So basically, that's APK is basically Dalvik code plus your resources. Apps must be signed, so each application you got to sign it. Now in the development mode, which is what we're going to be doing, it's going to be implicitly signed with something called a debug key. So you're not going to have to actually go and sign it, to just get signed by itself automatically. And another thing that I wanted to mention, many different markets, many different policies. So unlike iPhone, BlackBerry, Brew, some other ecosystems like that, where you sort of have the market, where you got to get approved to get in, and that's the only place to get the distribution from. Android sort of has multiple markets. So one big one is the Android market run by Google, right? But there are other markets. So I know Cisco is, for example, working on, or wants to work on an enterprise app market, right? Which is going to be sort of probably higher quality applications, right, than your typical Android market. The U.S. government also is working on something like that. T-Mobile, many carriers have their own markets, etc., etc. So it's a different sort of system than other ecosystems. It's much more democratic, sort of, or distributed, open, I guess. So that's basically that. Any questions on apps? Okay, so then let's talk a little bit about Java in Android. So I just want to point out a couple of things, a couple of differences. So as you know, in normal Java code, you write Java source code, you compile it, and you get Java bytecode, right? This is your dot class. And then you put that dot class file on top of JVM, and that's where it runs, right? With Android, it's slightly different. So we still write the very same Java code, we still compile it with the very same Java C compiler, we still get the very same dot class file. But then we recompile it once again to get the .dx file or .dex file or Dalvik executable. And it's that file that we now run on top of the Dalvik virtual machine. So that's where sort of it's different. So these steps are sort of additional. Okay, it looks like more work, but you'll see how tools just make this automatic. So you're not going to see these extra steps. It just happens. Quick question for you. Couple of questions. Why Java? Why use Java? Why not C, which is what everyone writes embedded code in? Or why not some more modern language like Ruby or Python or something like that? If you were creating a system like this.
There are a lot of Java designers available. That's why the probability of having good APIs is more for this Java.
Yeah, exactly. There are a ton of Java developers. That's, I think, the number one reason. Because Android was really not designed for the embedded developers. It wasn't designed for you guys, right? It was designed for all those kids who were writing PHP and other Java web applications up until recently. Now I want to do something new and cool, right? So that's sort of, it's a much more of a mass market appeal. And Java is a decent language for that. It may not be the ideal best language in the world, but it's okay, right? So given everything else, it's a good, well-rounded language. So that's a good reason.
So can we still write C application on Android?
Can you write C applications on Android? So yes, you can. But what do you mean by application? Is it as in an Android application or just a Linux application that's going to run on C? So here's the thing. I usually answer that question depending on who you are, right? So you can wear two hats. You can be an app developer or you can be a platform developer. Platform developer means you're shipping a new version of Android. And then you're God. You can do whatever you want. You can write new C code. You can install it. You're modifying the entire operating system, right? If you're an app developer, then Dalvik is the king. So everything is going to run on top of Dalvik. So that means it's going to be Java. But you can also write C code that's going to run as part of your application. But it's still going to run within Dalvik. So that's where NDK sort of comes in handy. Sort of like JNI in Java, right? So yes, you can have native C, C++ object code, but keep in mind that it's running on top of the JVM. So JVM is loading it, etc., etc. So it's still constrained by the same restrictions that the JVM is.
So there will be some performance.
Yes, yeah, there will be some performance differences, and sometimes order of a magnitude performance differences. I usually do this example with the Fibonacci sequence, and we do it both in C and Java, and then measure the difference, and it's about tenfold.
Wow.
Yeah. So, but and it keeps the same even if you do it iteratively or recursively. So it's kind of interesting, in terms of performance. So yeah. So that's the main motivation for having a native code, is to have some pieces of your code that otherwise need to be running faster. Yeah. Another question: Why didn't we go from Java source code then directly to Dalvik? Why do these extra steps?
You can probably compare other source code to Java, but
Yeah, that's a really good idea. One of the reasons why we inherit from Java bytecode is that you can then compile other code down to Java bytecode. So for example, I said Ruby or Python, right? So they can both compile to Java bytecode. So Java bytecode tends to be a very good runtime environment. right? For many modern interpreted languages. So JPython, JRuby, as I mentioned, are some examples. So that's a good reason as well. Another reason is Java compiler already does a lot of useful stuff. So we're basically just inheriting where we left off, right? So in that way we didn't have to reinvent the wheel that Java C already does. So that's another reason. But when I spoke with the Google team why they did it this way, their main reason for this choice was that back when they started this project was 2005, and that's when Java was going through a major change. That's when Java 5 came out. So in other words, this was changing, right? So they couldn't base Dalvik on something that was so in flux. So that's why they decided to base it on the bytecode for the most part. Make sense? So far so good on that? Okay, so let me just kind of point this out. So as you know, Java comes in different packages, right? So we have Java ME for mobile edition, Java SC standard edition, your desktop Java, and then Java EE, Java Enterprise Edition, right? So Android is neither of those, right? It's not any of the standard 3 Java packaging. The easiest way to kind of think about it is that we started with the standard edition Java. We took out anything that has to do with UI. So AWT and Swing. Anybody did AWT Swing work? A little bit, okay. So that's gone, right? So that stuff is gone, but that's been replaced with a bunch of Android-specific APIs. So this is basically the app framework plus replacement for UI plus, right? So a bunch of other stuff. There's some other things that are taken out of AWT and Swing. I think reflection and a couple of minor things like that. But those are sort of auxiliary things. I think AWT and Swing is sort of the biggest difference. So the UI is quite different. But the reason why this is sort of important is because you're going to be asking questions like, oh, what about Android networking, or what about Android I/O, or what about Android threading? Well, those things are the same as in Java. So none of that has changed, right? So you want to open up a file, it's the same as you open it up in Java. You want to open up a socket, it's the same as in Java. So those things haven't changed. There may be some other support on top of it, but for the most part, it's the same as in regular Java. Okay, so that's why I kind of wanted to point that out. Any other questions on that? Java, make sense? Cool. So let's then talk a little bit about the setup. So how many of you have set up the environment? Okay. Does anybody not have it set up? And are you guys using virtual machine or have it natively? Virtual machine. Okay, virtual. Both. Okay. If anybody wants, I have the virtual machine in a USB key. I can just pass it on to you. So let me know if anybody needs it. You guys know the advantages, disadvantages of running it natively. So in virtual machine, it's the advantage is I pre-configured everything for you. You can just set it up and run with it, and that's about it, right? It's pretty quick to set up. The downside is that it's based on Ubuntu, right? So some people are not familiar with the Ubuntu environment, and I can't legally distribute Windows, unfortunately, and sometimes it runs slower when you run it inside the virtual machine. So just kind of like a preference. Some people like it one way or the other. The reason why we have the virtual machine is because when I do short classes, then it becomes really hard to set up everyone's environment. Everyone's on a different system, and plus setting up Android is there are two steps, right? So first of all, for SDK, you need to set up SDK shell, then you need to download the platform, right? So that means that in the class where I have 10, 20 people, when everyone goes to do the second part, which they have to do then and there, it just clogs the network and runs slow, and we'll waste a lot of time. Similarly with Eclipse, it's a two-stage setup. You download Eclipse, and then you download the tools for Eclipse. So that always makes it really hard to do it in a class. I have attempted to, not me particularly, but somebody in the company, we've attempted to make setup much easier. So we actually, for native setup, so without the virtual machine, so we actually now have a development environment which is pre-configured Eclipse and pre-configured SDK. So as opposed to having to do the second stage for every single one of them and take time, we have pre-downloaded that and repackaged it. So if anybody wants it, I have it for Linux, Mac, and Windows as a different environment. So just so you know. It's on the USB key, so you're welcome to use it. Now, let me walk you guys through the SDK and kind of explain it. So you installed SDK, you have a directory, something like Android SDK or something like that, right? So inside of that directory, you're going to have a bunch of subdirectories. There's going to be one called Tools, and Tools is a directory where a lot of common SDK tools go into. Okay, it's highly recommended that this particular directory you put in your path. Everyone knows what I mean by that, right? In your environment path, right? Are you guys on Windows or Linux?
Windows.
Mostly Windows. Mac. Okay. Mac. Okay. Okay. So nobody's on Linux. A couple of you are on virtual machine, yeah. Okay, so and you're okay with Ubuntu and all that. Okay, perfect, cool. So, okay, it's for the most part things are the same. I'll point it out where it's not, but for the most part everything we do we're agnostic to the actual platform. So tools is where your tools are. So put that in a path. We're going to be seeing some of these tools as we keep on going, and we'll see them as they make sense. So we're not going to see them right away, but I'll point them out as they make sense. Now, the next directory that is very important is the directory called Platforms. And inside of Platforms, you're going to have any number of different subdirectories. What Platforms is where you plug in a specific platform you're working on. Okay. So remember I said it's a two-stage download. So before it used to be very simple. When we had Android 1.0, you just download SDK and you have everything. 1.1, you go download SDK and you have everything. And then they noticed, hey, we're repeating a lot of stuff. There's stuff that's common, right? So then they came up with basically the shell of the SDK in which you plug in different platforms, right? So right now I have two platforms. I have Android 4 and Android 8, meaning I have Android 1.6, aka Donut, right? And Android 8, aka Froyo, aka 2.2. And that's totally fine. Yes, on the VM, what I did is I worked really hard to make it as small as possible, and that's why you only need one platform. It doesn't really matter which one we work with. So as long as you have one, I don't really care about anything else. So that's why that's fine. Did you guys download the 1.5 gig or the 9 gig of virtual machine? Virtual machine 1 or virtual machine 2?
We only see one.
Okay, how big was it? How big?
About 4 gigs, I'd say. 4 gigs.
Okay.
7 gig.
Okay, that's fine. So you basically download. So let me explain that. I have two versions of virtual machine. And the only difference is that the bigger one, which is what you have, also contains the source code for the entire Android platform. That's because I use it for the internals training as well, when we actually built from scratch the entire platform, right? And the source code for Android is about 2.3 gigs on it by itself. Plus there's a bunch of other stuff that comes with it. So that's why it's a little bloated, that virtual machine. So that's totally fine. If you want to make it smaller, you can just blow away the directory called Froyo in your root. But other than that, it may be useful to have source code handy, so it doesn't hurt.
Does the Agile directory also include the Linux source code? Or
Which one?
the Agile directory, does it include the Linux source code? When you build, does it build everything or just only build Agile?
when you build the entire Android, it actually contains everything, including the SDK, the NDK, the Eclipse tools, basically the entire.
The kernel, right?
Yeah, except the kernel is part of the pre-built packages. So it does contain kernel, but in a binary format. Right, so the kernel itself is part of the pre-built packages, yeah.
But if we have a new driver, let's say if we have a driver for Android, it will be part of this platform?
Yes, there's a place for you to put that driver in, yes, you could plug it in. Yeah, and then when you build it, you can build for different targets. So you can say, I'm building for CS, or building for generic, which will be emulator, and so on. So you can kind of configure what you're building for. So inside of these platforms, again, it doesn't matter which one you have, as long as you have at least one. So there's a couple of subdirectories as well. One is tools, which is the platform-specific tools. Don't worry about that too much. That's going to be used automatically. There's a platform for skins, which is basically the skin is the look and feel of a device in the emulator. So do you guys have a skin for CS? Anybody knows? The look and feel for CS? So basically what the skin is, it's kind of like, this is what the phone looks like. It's got 1024 by 768 and it's got buttons at the bottom, right? So that sort of stuff. So I'm sure somebody somewhere has created a skin for CS. But these are some default ones. And then one directory that's actually very important in platforms is this directory called images. Okay, and images is not graphics. Images is basically the file system images. Okay, so you technically have 3 files. 2 of them are important. System.img represents the entire Android system when it's built. Okay. So it's usually about 50, 60, 80 megs of stuff. But this is essentially what the system partition on your device looks like. This is the equivalent of like, C:\Windows on your Windows, right? So it is the entire operating system. Everything is in there, in binary format, built, right? User data corresponds to the user partition. So it's usually much smaller. It's a couple of megs, right? And then it keeps growing, right? And then RAM disk is tiny. It's just a RAM disk. And this is the kernel for QEMU, which is the emulator that we're going to use. So I'll talk about that in a second. Okay. So that's all you kind of care about in terms of the platforms, right? So as I said, each platform you download is going to have a different directory here. Now, are you guys familiar with the, just version numbers, what it means Android 8 versus Android 2.2? No?
Yeah, can you explain that?
Yeah, let me I'm going to use, I used to have that slide, but I took it out, but I moved it to a different place. So this is what that really means. So we are all familiar with these versions, right? 1.0, 1.1, 1.5, 6, and so on, right? And you guys you've heard of nicknames, right? When they started nicknaming versions, they were gonna call them after robots. So the first one was Android, but then they couldn't come up with a B. So they switched to pastries, right? So that's why we now then have cupcake, donut, eclair, froyo for frozen yogurt, and the next one is gingerbread, and so on, right? So it goes alphabetically, and it's something that's yummy usually. So those are nicknames. Now, the most important type of a number is this number, API level. And what API level is the capabilities of the platform, right? So for example, was there a version 1.7, 1.8, 1.9? Probably. Did we care about it? Probably not, because it was most likely just bug fixes, performance improvements, etc. In other words, there was no changes to the API. So you as an app developer don't really care. The API stayed the same. But whenever API changes, even slightly, this number gets jacked up by 1. Right? So we're right now at API level 8, which corresponds to Android 2.2, which is nicknamed frozen yogurt, right?
Is that backward compatible?
Hmm?
Backward compatible. Like someone writing something with API 1.
Yeah.
It run on API 8.
Yes. So everything is backwards compatible. They may deprecate some code, which is basically marking it for, don't use it, but yeah.
When you create Android project in Eclipse, you select the API level or Android version, but then at the bottom it asks you for the minimum version. So why would you choose a different minimum version? Like, why do they have that when you're already saying that using
Yeah.
whatever?
That's a great question, and I'll talk about it more later. But let's kind of take a look at the distribution. And this slide is slightly old. This is July 1st. Keeps changing all the time. I did a presentation for your upper management for Barry's team, so it's the data from back then. But here's the distribution. Basically, a third of people are still stuck at 1.5, and so basically about half people are still running 1.5, 1.6, right? So now when you're writing an application, it's up to you. Do you want to care about this other millions of people or not, right? So in other words, you may say, look, I want to take advantage of the latest, greatest things in Froyo, right? But I would also like to have a large market share, right? So you may say in that case, I'm going to design my app for Android 8, but I'm going to support as far back as Android 4, right? So for example, if a certain feature is not available because user is running old version of Android, you can gracefully scale down to that version. You can disable a single button or single feature in your app as opposed to not have the app run at all, right? It's kind of like the latest Windows software may be designed for Windows 7, but it's going to run as far back as Windows 95 or something, right? So you want to gracefully scale down, right? For example, Bluetooth doesn't exist up until version 5, so I may basically just disable support for Bluetooth devices in my app for older versions, but my app is still going to run, minus that one feature. So that's the reason why that exists. And a lot of people are getting update. So let me show you this. And again, it's dated, but the picture is interesting. So see how people are still a lot of people are still stuck more or less on 1.5. A lot of people are still stuck more or less on 1.6. This is kind of, they're getting squeezed out, but not fast enough compared to like 2.1. Almost nobody's running on 2.1 anymore. We just new release, bam, everyone got updated, right? So in similar for 2.2, new release, bam, people really quickly get updated. The thing is, so new releases get pushed to users via over-the-air updates, right? Now, older devices, the firmware simply doesn't support that. So for example, HTC sold millions of G1 devices, right? But they're not capable of 2x Android. And HTC is so busy with new products, they don't have time to deal with the old stuff. They're just not motivated to deal with that. So that's why, and the way it works in America is you buy a phone under a 2-year contract. So basically these people here, they're stuck for 2 years, right? That's why this line kind of is going out slowly. Okay.
You cannot install new, like 2.2 based on the G1 phone.
So it's not, can you install it? You can, we've done it in the office. We have Froyo running on the oldest phone, G1. It's not supported, it runs really sluggishly, right? And it's not an official release. So, but yes.
So the reason you want to upgrade to the Android from 1 to 2.0 because you try to run more application.
Well, 2.0 just has more capabilities. Right, so for example, everyone now wants to get to 2.2 because it's got just-in-time compiler, making your code 2 to 5 times faster. So everyone wants the latest, greatest, right? Now, when Gingerbread comes out, 1 gigahertz is sort of the minimum, So even if you have an older Droid or something like that, it may run sluggishly or not even be supported by the manufacturer. Right. So there is the open source Android, but then there is a layer that each manufacturer needs to provide, which is basically all the drivers and everything, right? So we do depend on manufacturers to actually roll out the firmware updates as well. Yeah.
The OS updates, those are pushed by the manufacturer or by Google?
No, they're pushed by the carrier.
The carrier.
So technically, it's pushed by the carrier, but the carrier works very closely with the manufacturer to get those updates. Not necessarily with Google. So Google is sort of working on the open source version of it, and they may work closely with a couple of manufacturers to sort of get it right on their devices, just being pragmatic. But Google in itself is not really, it's not their job to push the updates other than for Nexus One and the phones that they support. Yeah. So that's sort of how that works.
So what is the major difference between Android 1.0 and Android 2.0? Just the link fast?
Well, the capabilities of the API keep changing all the time. So there's new features all the time, right? Better support for this, better support for that. So
It is also the application oriented. Even some of applications can run over there, can run over there.
so certain applications could be taking advantage of certain things that are only available in the latest version. So they may or may not be able to run on the older versions. Yeah. Cool. So let's do. So now that we kind of talked about all the bits and pieces of the SDK, let's do a simple application Hello World, just to kind of test that you guys have everything working, and set it up and kind of go from there. So what I'm going to do is I'm going to open up Eclipse, and let me see if I have any previous Hello Cisco projects. Let me delete. So we're going to create a new project. So go to File, New, Android Project. If you do not have Android project available there, you probably did not install Android tools for Eclipse, ADT. Otherwise, if everything works, if your Eclipse so far is configured properly, you should have a window like this. It's called the new Android project. Oh, by the way, one directory I did not mention. So just back in SDK, there's another directory called add-ons. Okay. So add-ons is basically very similar to platforms, except it's the third-party releases of Android. So what does that mean? So for example, you guys may have a different version of Android for CS. You're likely going to have that, right? You're going to have a modified version of Android. It's going to support some special stuff, right? Maybe there's like, licensing support, like some special sauce that you created. And you may want to roll it out to developers so the developers can develop for your version of CS. Okay, so what you would do then is you would release an add-on, right? So these are just some add-ons that I kind of made up here. But one common add-on that's well known is, for example, Google add-on for Android. So for example, yes, Google does have the team that works on the open source Android, but then they also have a team that works on a proprietary version of Android. So when you get a phone from T-Mobile or somebody and it says with Google on it, you likely have a different version of Android, a non-open source version, a commercial version of Android. What's the difference? So it's got Google's secret sauce. For example, Google Maps, right? So that's one thing that's not open source, right? Google App Market is not open source. So in other words, if you want to have an Android that has certain things pre-configured, pre-installed, certain libraries installed, such as navigation, and so on, then you need a different version of Android.
Does it mean you need to pay the royalty to Google?
Yes, so it means that it's licensed. Now we indirectly pay to our carrier. I pay to T-Mobile. T-Mobile then has some licensing agreement with Google and so on. But that's a pretty common situation. So almost nobody runs a vanilla Android out of the carriers. So carriers work in the States, at least. Carriers work very closely with OEMs to create proprietary versions, right? So HTC is probably, in my mind, the best example. So HTC has their whole Sense UI. So you've seen their phones; they look much sexier than a regular Android phone, right? The apps are nice and flashy, and it's very much like an iPhone experience. So that's the kind of work that HTC does. So they take regular Android, they build on top of it, right? And then that's what they provide to carriers.
So when you're writing an app, you're actually going to get add-ons from all the vendors to test on it?
Well, you can if you want. You don't technically need it. You only need it if you're using that carrier's extra. So for example, unless I'm writing an app that is using Google Maps, I don't care about Google Maps API. So in that case, I would just write for standard Android platform. And most of the work I do, I just write for the standard Android platform. But if, for example, HTC may not ever want to release their libraries to other developers because they're just not concerned about other developers writing special stuff based on HTC stuff. But for example, maybe Cisco has added support for multi-users to CS, which is something that you guys are interested in, right? So support multiple users, so I can actually log into the device, right? So if there is something like that, and I want to develop apps that take advantage of multi-user system, then I would expect Cisco to deliver libraries to me, and those libraries would be in the form of an add-on. So if you take Google,
So this API you have here right now, I mean, we don't seem to have it in the beginning of install, so what is that? The Cisco API?
these APIs here.
The Cisco API that you have on the
Oh, this is Cisco API. I just made it up.
Oh,
These are all. I was just doing an example of what it would take to. But what would it take for you to create a new add-on? How hard is that? So basically, let's take a look at the add-on. So add-on, okay, yes, you may provide some documentation, you may provide some sample code. That's not that important. But ultimately, you may have some libraries. So for example, I said, I copied probably the Google on. So there's a jar file with some secret sauce that I as a developer would need to link against, right? But ultimately, the most important thing is going to be another version of system image, right? So what you would do to create a new version is you would go, if you're on a virtual machine, you go to that directory called Froyo, you would type make. You would sit back and relax for about 6 to 8 hours, okay? And that would produce the new version, that would compile the source code for the entire platform, the result of which would be system.img. So this is now a brand new version of Android that gets flashed onto the device. But for a developer, you can also include it this way so the developer can develop against that. Right? So that's what that is, add-on. Cool. And you guys don't have it, but again, it's not that important for now. Don't worry about it at all. You can, if you wanted to download it, I'll show you later on how to do it. So back to this directory. So I just want to do a quick hello Cisco project. So that's a project name. So the project name is just an Eclipse construct. Eclipse organizes everything in projects. Then you need to pick the target. In other words, what you're building this project for. And what I have here is the list of all target platforms and add-ons. It's a union. It's a union of these two folders. Oops. These two, add-ons and platforms. That's why I have 5 things, 6 things. You guys have only 1, right? So that's totally fine. Don't worry about that. We're gonna just base everything on just Android 8 or 2.2. So next, what it's asking us is for application name. Application name is just an arbitrary name. So hello, comma, space, Cisco, exclamation mark.
Let's say if we try to develop a software for multiple platforms, are we able to get those items from the different companies, something like Samsung, Qualcomm? If they're willing to release this,
If they're willing to release, yes, you would be able to get it from. They just need to release it. I don't know what they're at with releasing that. I recently spoke at a Sprint conference, and I know Sprint is sort of, they have their own stuff, and so everyone's trying to release that. So I'm not sure how much they're promoting that. It could be you need to sign up for the developer program. But yes, that's how they package it. Yes.
But the situation is getting more and more complicated. Let's say the manufacturer, the equipment provider have their own library, those kind of thing. And eventually, the carrier may have their own.
Yes.
So you may need to combine both and create your own matrix and then.
Yes, but so but then the question is, it's also for example, if Sprint, HTC, let's take those two. So if Sprint has their own libraries and HTC have their own libraries, the question for you as a developer is, do you want to develop something that's really dependent on both Sprint and HTC? Because they need to really give you something that highly motivates you to use it. Otherwise, why would you develop your app that only works for HTC Sprint phones as opposed to millions of other phones? So you as a developer typically want to have as wide of a reach as possible, right? So, but the vendors would like you to lock you in. So that's kind of like everyone's got a different goal. Okay, so next after application name, it's a package name. Package name is a Java package, and it's very important. It's gonna trickle down into security and signage and a whole bunch of other things. So it's as such is very important. In Java, as you know, we typically do a reverse of your domain name. So it'd be something like com Cisco hello, for instance. That's typically what the Java package name would look like. Optionally, we can create an activity. We haven't talked about what activities are quite yet, but it's roughly a screen. And that screen is represented by a Java class. So whatever we put here is going to be a Java class name, right? So it needs to be, for example, hello Cisco. So capital H, capital C, right? So it's got to adhere to class names, right? It's standard. And then it's asking for a minimum SDK version. Back to your Verol's question about what that is. So in the past, this number would just come right from here. So it would just take this number and copy it, because they were always the same, right? But now we're realizing, hey, it doesn't have to be the same. Maybe we're targeting the latest, greatest, but supporting the older version as well, which is the best practice. So that's why that number now is smaller, could be smaller, right? You hit enter, and bam, it creates a new project for you, new project, and so that's basically where we're at. So does everyone have this project so far? So everything works so far? Okay, so because we're about to take a break, and I just want to know if you guys have any problems with the setup. I can help you out during the break. Make sure that we sort it out and kind of go from there. But then.